Today's notes are on logarithmic functions. Please complete the warm-up on your own and then take a look at the box below. When you have to solve an equation for an exponent, you use a function called a logarithm. The logarithm of a number is the exponent to which the base must be raised to produce a given number. In logarithmic form, it is written as log base b of y equals x. In exponential form, it is written as b to the x power equals y. Logarithms and exponents are inverses of each other. Equations can be rewritten from one form to the other. From log form into exponential form, log base b of y equals x becomes b to the x power equals y. So for example, log base 4 of 10,024 equals 5 is equivalent to the base, which was 4, raised to the power of x, which is 5, equals the y value 10,024. And you can confirm that in your calculator. 4 to the 5th power does in fact give you 1024. Going from exponential form into log form, b to the x power equals y becomes log base b of y equals x. So 3 squared equals 9 is equivalent to log base 3 of 9 equals 2. How can you remember this? The base always stays the same and the log is equal to the exponent. We're going to move down and look at example 1, rewriting each equation in exponential form. So for 1a, we're going to do the same thing as we did before. I'm going to keep the base, which is 2, my y value, which is 32, and my x value, which is 5. And I have b to the x power equals y in exponential form. Please try and rewrite example b on your own. For example 2a, we are going to rewrite the equation in logarithmic form. So my base is 2, my x value is 3, and the y value is 8. This becomes log base 2 of 8 equals 3. Please try and do example b on your own. Log base b equals 1, log base b of 1 equals 0 because b to the power of 0 equals 1. Log base b of b equals 1 because the base raised to the power of 1 is still equal to itself. We can evaluate logarithmic functions by changing the problem into an equation in exponential form and finding x. So for example 3a, I'm going to rewrite this in exponential form. And since we're trying to find what this is equal to, I'm going to say 3 to the x power is equal 81. Now I need to think 3 to what power gives me 81? Or I can think about rewriting 81. I can rewrite 81 as 3 to the 4th power. And since both sides have a base of 3, I can say that x equals 4. For example b, I'm going to do the same thing where I have 1/2 to a power of x equals 8. Because it's hard for us to rewrite 8 as 1/2, I'm going to first simplify this by changing this to be 2 to the negative 1st power in order to get rid of the fraction. This helps us because now I can rewrite 8 as being 2 cubed. And once again, since the bases are equal, I can set the exponents equal to each other. So negative 1x equals 3, or x equals negative 3. Please try example C on your own. The common log is a log with a base of 10. That is the value of log on a calculator. It looks like either log base 10 of x or a log of x. The natural log is a log with a base of e. It is the value ln on a calculator and looks like log base e of x or the natural log of x. For example 4, please use a calculator to evaluate the expression to 3 decimal places. So you're pressing the log button on the left side of your calculator and then 5 and checking that you get an answer of 0.699. Same thing with the natural log. Hit the natural log and then 0.01 and check that you get an answer of negative 4.605. And for part C, log, and then put parentheses 1 divided by 8, you should get negative 0.903 as an answer. Remember that the log and natural log functions and exponential functions are inverses and cancel each other out. So if f of x equals b to the x power and g of x is equal to log base b of x, then f of g of x equals x and g of f of x equals x. That means that f of x, or f of g of x, is equal to b to the x power, but instead of x, I'm going to plug in log base b of x, which simplifies to x, and g of f of x is equal to log base b, and instead of x, I'm plugging in the f of x function, b of x, which also simplifies to x. We're going to use the inverse properties to help us simplify each expression. When you have a log of a base raised to the same power, you can say that the expression is equal to the exponent. So log base 5 of 5 equals y. Similarly, if I have a base raised to power of a log with the same base, such as 7 log base 7, I can say my answer will be 8. And for example C, 10 times log base x, remembering log of x has a base of 10, my answer is just x. We will go through the remaining examples in class.